Live. Okay. All right. Here we go. I'm dropping things. So, page 76. It is 10:4:18. All right. So, first of all, let's go to parabola. What we know about a parabola is it usually comes from some y equals x squared equation. Thank you. Okay. It's called a quadratic. Every parabola, or every x squared equation is going to be a quadratic. And part of the reason we call it quadratic, and I don't know if you've learned this yet, there's a thing called the quadratic formula, which we're going to use in here eventually, and that's one of the reasons we call them quadratics. Don't worry, we'll get to that later. Now we know that if you take a look at a parabola, okay, any parabola anywhere, that we know that it looks something like this. Or it could be upside down. It could be upside down. But a parabola looks something like that. It has a very bottom point that we call the vertex, okay? So my vertex, let's just say, is some point h, comma, k. Now h and k are just variables to represent numbers, right? It could be 3, 2, it could be -4, whatever. But, you know, the vertex would be the very bottom spot or the top, right? We know that a parabola is symmetrical, and it's symmetrical right down its vertex, right? So it has an axis of symmetry, and the axis of symmetry goes right through the vertex, doesn't it? It has to go through the vertex, goes right through the vertex. So the equation of the axis of symmetry, it's an x equals equation, because if we graph x equal lines, they're the straight up and down lines. Okay, x equal lines are straight up and down lines, okay? And it's x equal whatever the vertex is. So the axis of symmetry is always going to be some x equals equation, and it's always going to be x equals whatever the vertex happens to be. That makes sense, doesn't it?
No.
Okay. All right. So we're going to take a look at this, and hopefully it will make sense when I get there. Okay. But axis of symmetry goes right through the middle of the parabola, right? Has to go through the vertex, which means it's got to be an x equation to whatever the x value of the vertex is. Okay. Now, if we take a look at their nice little chart. Increasing, decreasing. That's pretty simple. Where's the graph going up, and where's the graph going down? Now, some kids will say, gosh, Mr. Davies, isn't it going up? Right, I'm going up. But we always read from left to right, correct? We always read from left to right. So as we move along the x-axis, it's going downhill until you hit the vertex, right? And then all of a sudden, it's going uphill from the vertex. So increasing, decreasing are x values, okay? So in this case, the vertex is at 0, 0. That's my vertex. So we're going to say it's increasing from x is greater than 0. From x is greater than 0, it's going uphill. Now it's coming downhill prior to that, right? So we'll say it's decreasing from x is less than 0. Right at 0, it's neither increasing, decreasing, it's just at the bottom of the hill, right? At the bottom of the hill, you're not going up, you're not going down, you're just at the bottom, right? So you're coming downhill when x is on this side of the graph, coming downhill, and you're going uphill from this side of the graph, okay? Thumbs up so far? Does that make sense? So it's always going to be at the vertex, where it either goes up or down. Okay, let's move it on over, okay? Now, let's look at example 1 and example 2, okay? So it's identify characteristics of the quadratic function and its graph, all right? So first of all, right at the bat, I know this. I know it's going to be some y equals some positive x squared, okay? Some positive x squared. I'm going to put a little plus sign here, okay? Because it goes up, right? You guys agree with that? It goes up. And I know this one's going to be y equals some negative x squared because it's a frowny face. It's that easy. Positive x squared, it goes up. Smiley face. Negative x squared, it goes down. Frowny face. That easy, okay? Now, the vertex of this one, the vertex happens to be at -1, 1, right? And the vertex of this one is at 3, 1, 2, 3, 4. 3, 4. These work just like your absolute values. Just like your absolute values. But we're squaring them. They're squared. So this equation would be y equals, you ready? An x plus 1 squared plus 1. Opposite of the inside, right? And it has to be a squared because it's a parabola. Opposite of the inside, right? So I'm at negative 1, 1. Okay? So my vertex is at negative 1, 1, so it's the opposite inside, right? This equation should be a y equals a negative because it's upside down, parentheses, and we're going to go x minus 3 squared plus 4. Okay, just like the absolute value graphs, except for it's just a parabola. That's all. We've done this sort of thing before. Opposite of 3, I want negative 3, and then plus 4. Negative because it's upside down. Okay, thumbs up so far? Okay, okay. I'll wait for you. Okay, when I graph a parabola, I like these numbers. Okay, listen. 0 squared. Zoe, what's 0 squared? Good. Okay, Grace, 1 squared. 1 squared. Good. Owen, 2 squared.
4.
Caleb's a hard one. 3 squared.
I don't know this one.
3 squared.
It's gotta be something like 9.
Okay, here's a trick question. Julia, negative 1 squared. It is a 1. It's positive 1. It's positive 1 because a negative times a negative is a positive. All right. Hannah, it's a trick question. Negative 2 squared. 4. It's got to be a positive 4 because we know a negative times a negative. All right. Ellie. Negative 3 squared. Positive 9. So if you look at our parabola, okay, here's one way we can graph every parabola. If you find the vertex, we're going to go over 1. What's 1 squared? 1. Over 2, it's 2 squared. 1, 2, 3, 4. Over 1, 2, 3, what's 3 squared? But it's not on there. And we know it's symmetrical because we know negative 1 squared is 1. Negative 2 squared is, okay, look at this one. Same way, watch. Go to the vertex. Over 1, what's 1 squared?
1.
But it's down, it's negative, right? 2 squared is 2 squared? 4. We're going to go down 4 because it's negative. Okay, see how that works? Really an easy way to graph parabolas. Okay, turn the page. Okay, now let's take a look at, first of all, number 3. Okay, go to 3. Now, on number 3, real quickly, what's the vertex? What's the vertex? 0, 0, okay? Totally correct. 0, 0 is correct. Now, I could get a little bit wordy on this one, and I could say, well, it's the same thing as g of x equals 5 times an x minus 0 squared plus 0, but that would be a waste of time, right? Wouldn't that be a waste of time? But that helps us get to 0, 0. Right, Josiah? Okay. So we can go to 0, 0. And then what's going to happen with the 5? How does the 5 change things?
It just takes the results. So,
right.
So like if x equals 3, it's going to be 18.
Yes. So if we did our 1 squared, our 2 squared, our 3 squared, you with me? What's 1 squared?
1.
Now let's go 5 times that. 5. What's 2 squared? Now let's go 5 times that. Let's go 3 squared is
27.
9, and let's go 3 times that.
18.
45, okay? So if we have to graph this one, I think I'm going to keep this 1, 2, 3, but I think I might go 10, 20, 30, 40, okay? So that I can get the whole graph to fit, right? So if I went 0 times 0 is 0, right? But if I go over 1, right? 1 squared is 1, but we're going to be 5 times as tall. So I went up to 5, didn't I? 2 squared is 4, but I'm going to go 5 times as high, so I'm going to go up to 20. Am I making sense on this? Okay, we'll wait for you and I'll do another, okay? I sometimes go too fast, huh?
Oh yeah, you are right.
Okay, 3 squared is 9, but I'm going to go 3 times as high, so we're going to go up to 45.
mean 5 times as high?
5 times high. Did I see it wrong? Yeah. So I'm going to go to 45, which is here. Now, my parabola looks something like this. However, I don't have to worry about the other side. I'm just going to reflect it over, correct? I'm just going to reflect it over. So should have a point here at -1, and a point here at -2, and a point here at -3, and there's my parabola. Try and make them a little bit curvy, because they are curvy, they're not pointy. Okay, they do curve out of the bottom. Okay, does that seem easy? Okay, how about number 4? Okay, let's look at 4.
Vertex is 0?
Yeah, vertex is at 0, 0, totally right. Vertex is at 0, 0, okay. And then, I know this one's going to be upside down, okay? It's going to be a frowny face. It's going to be upside down. It's going to be a frowny face, right? And it's going to be 4 times as tall. So when we do our 1, 1, 1 squared is 1, but we're going to multiply that times -4, right? Yeah, we go to -4. We do our 2 squared is 4, but we're going to be
16.
-16, right? We're going to do our
No.
3 squared is 9, but we're going to go -4 of that, -36, right? So I'll go by 1s on my x-axis, but I'm going to probably go by 10s again, -10, -20, -30, -40, and I should be able to get my parabola in there, okay? Upside down because of the negative, and 4 times as tall, right? So, if I start at 0, 0, which is the vertex, if I go over 1, 1 squared is 1, but 4 times as tall, so let's go down to -4. Over to 2, 2 squared is 4, but I'm going to go 4 times that, -4 times that, so I'm going to go to -16. 3, 3 squared is 9. We're going to go -4 times, so it's -36, right? So I'm going to go -36. And we know it's symmetrical, right? So we can put the values on the other side.
I do.
Yeah. Okay, does this seem pretty easy? Hoping it is. All right, let's do one last one. Let's do number 8, okay? Slide it up to 8. Am I going too fast? Okay, slide up to 8. All right, so again, let's start right here at the easy part. Where's my vertex?
0.
Okay, it is 0, 0, right?
It'll be negative.
Right? Is this one going to be a smiley face or a frowny face? Smiley face, because it's positive, right? There's a positive 0.6, so it's a smiley face, right? And what I'm going to do is take my, my 1 squared is 1, but then I'm going to multiply that by 0.6, right? Which gives me 0.6, right? Gives me 0.6. I'm going to take my 2 squared, which is 4, and then I'm going to multiply that by 0.6, which is what? 2.4? 2.4? 4 times 6, 24. How about 2.4?
Yeah.
You okay with 2.4? I know it. It's, you know.
No, I'm not.
2.4. Okay. 3 squared is 9 times 0.6 is what? Okay. 9 times 6. How about 5.4? You okay with 5.4? Okay. So when I make my axes this time, I'll go by 1s. 1, 2, 3. But I might go by, let's see, 1, 2, 3, 4, 5. So I'll go by 0.5. So there's 1, 2, 3, 4, 5, right? So I'm going to go by 0.5s so that my graph fits.
Wait, what?
I'm going to go by 0.5s. 0.5, 1, yeah. And then we'll just put our points in. 0, 0. At 1, we're at 0.6, so it's about there. We're just estimating. At 2, we're at 2.4, which is about there. And then at 3, we're at 5.6, which is about there, which is estimated. Okay. And we know that it's symmetrical, right? So we can put the other points on the other side. Okay. There it is. There it is. And there it is. Okay. Now, I don't have a lot of homework on the computer for you. Okay. It's just about maybe 6 problems. And then the egg drop's got to be done. So we have plenty